Hi all, good evening. I am Sandeep and welcome to my YouTube channel. Today in this video, we are going to prepare question answer type of data, and then we'll later convert and make the data in the right format for the LLM fine tuning, and then later we'll using that data we'll do the fine tuning of LLM that we'll choose, and later we'll do the evaluation of that fine tuned LLM model. So it's complete end-to-end project. Please make sure you watch this video till the end. It's going to be a thrilling experience. So let's dive in. So before that, let me tell you that you might have watched already this my earlier video on the LLM fine tuning, that is fine tuning DeepSeek R1 LLM with the custom data with the Unsloth LoRA SFTTrainer step by step, where I explained the fine tuning of this DeepSeek R1 LLM with the custom data. I explained step by step with details. So if you have not watched yet, please make sure you watch this video because this is the part 1 of the fine tuning LLM, and today's video is the part 2 of that. So let's get started. Okay, so this is fine tuning of LLM with our own FAQ, that is the frequently asked question type of data. Then we'll do the preparation of data from the scratch, and also LLM fine tuning with the Unsloth library. So in this project, preparation of QA question answer type of data, FAQ type of data, frequently asked question. So we'll prepare the data from the scratch, then we'll convert and structure the data in the right format, that is Hugging Face format for fine tuning of LLM. And then we'll do the fine tuning of LLM, and we are going to choose Llama 3.2 3 billion model, 3 billion parameters. That is relatively smaller in size. It would be easier for us to handle in Google Colab. So we'll do the fine tuning with that data, our custom data, which we'll prepare, and then finally we'll do the evaluation of the fine tuned LLM. So fine tuning of LLM is done with the Unsloth library using the LoRA, low rank adaptation technique, and then supervised fine tuning trainer, SFTTrainer also. So as you know, Unsloth reduces memory usage and makes the fine tuning faster. So model was fine tuned, trained for 15 complete epochs on Google Colab. So we have trained for, say, let's say 15 complete epochs on Google Colab GPU. And before fine tuning model, basically I tested the model with some questions, and as expected, our LLM failed to answer because it has not yet been trained with that. And then the model was liberated later after fine tuning, and the same set of questions we asked the LLM, and it could answer all the questions properly. We could see the effect of the fine tuning quite well, and all the answers were answered by the LLM properly. So I'll first show you the data. So this is a PDF file which I prepared. Let's say there is a company called A to Z, and they have a product called Damini. And this PDF, this contains the FAQ, frequently asked questions, and their answers about this product called Damini of this company A to Z. So I basically collected information, or that sample questions from various sources. Then I made a lot of modifications, compiled them, all of them, and then I put them in a PDF actually. If you look at the question, there are general information. What is the primary function of the product Damini of A to Z company? And its answers are also given. What is the target audience of this product Damini? What are the key features of the product Damini? Then technical aspects. What type of the data formats does the product Damini support? Okay. Then what are the different deployment options available for Damini? Then what are the system requirements for using this product Damini, etc., etc. Pricing and billing. How is the product Damini priced? Then what are the payment options? And so on. Customer support related questions. How can I access customer support for product Damini? What type of support are offered for Damini? And so all the question answers are given here. Data security and privacy. How does the product Damini protect my data? Okay. And what are the data residency options for Damini? The important consideration. What are the limitations of this product Damini? Then how can I provide feedback on this product Damini, etc., etc. So total, I think 15, 16 sets of question answers are there. So this is our starting point. This PDF is our starting point which I prepared. So our goal is to use this PDF data, and then we have to extract the question answers from this PDF file and make them in proper right format, structure them in right format for the LLM fine tuning. So we'll do step by step. So for that, we have written a simple Python script, and here we'll use another LLM model which will help us with the structuring of data preparation. Okay. So here first we are importing this GenAI from the Google, and then from .env import load.env, which contains which will load all the environment variables, load.env. Then from LangChain community document loaders, we are importing this PyPDF loader. Okay, PyPDF loader. So our PDF file is faq.pdf, and then with this PyPDF loader, we are loading this PDF file. Then we are extracting the text data from that, as you can see. Then we are creating one schema, this output template. So this schema, basically, as you can see, the structure, basically it's a JSON structure and sample JSON structure. It's a basically list of JSON objects, and there is a key called conversation. Under conversation, there are also dictionaries, the role, user, content, question, and role, assistant, content, answers. So we are providing this schema to LLM output template, and then basically this GenAI from Google we have already imported. Client equal to GenAI.client. Then we are passing the API key, Gemini API key you need. So we are going to use the Google 2.0 Flash model here. So response equal to client.models or generate content, and then we are passing the model, the Gemini 2.0 Flash model. And then here is the prompt, content equal to. So triple quote, start with the triple quote. If start with the triple quote, you are a data preparation expert. Please go through this final text data, this one. Final text data we have already extracted from the PDF. They're passing that text data. Go through this with the question and answers, and then separate the questions and answers and write them in JSON format with the given schema. Output under this one, output template we are already passing to the prompt, LLM prompt. So it has the schema, it has the context also, and so output should comply with the given schema, and then output should contain only the JSON data, nothing else. Okay. So you have to write it very clearly. These instructions or prompt you have to give it very clearly, and then Gemini 2.0 Flash model that will extract the data from this final text format, and separate the question answer, and then make them in this JSON structure data. Okay, then find output is equal to response.text. Response.text, and then here we are doing some here we are doing some cleanup. Actually, first line, last line we are deleting because first line and last line contains some unnecessary characters. So we are removing the first line and last line, and that's it. So you have the final JSON data. So if you look at this, it will look like this. Okay, conversion. So I will make it visible to you in Google Colab. When you will be in Google Colab, you will see it clearly, this JSON data. Now go to Google Colab. I will explain to you each and every step. Okay, so in the Google Colab, first you have to install these libraries with the given versions: Unsloth, Unsloth_zoo, Torch for PyTorch, the Torch audio, Torch vision, etc. So make sure you install all of them as specified here, and then you can like from Google Colab import drive, and then drive.mount. You have to your local Google Colab this area content drive, you have to mount it here so that you can access if you upload any file, so that you can access it here. Okay, then load the original model and tokenizer. That is a part of that, So from Unsloth, import this class called fast language model, and also import torch. Then maximum sequence length you have to specify here to 2048. Data type equal to none, it will pick up automatically. Then load in 4-bit will be used for 4-bit quantization. Will enable the 4-bit quantization to reduce the memory usage. So model tokenizer is equal to fast language model dot from pretent. Then specify the model name Unsloth class. So you have to make sure that it is a part of the Unsloth. So you go to the Unsloth site documentation, and here all the models are listed, and you can pick up your model. Any model you can fine tune with this, with your data or any other data. So I have chosen this one Llama 3.2 3B because it is relatively smaller in size, easier to handle. So Llama 3.2 3B, this model I have 4-bit. This one I have, and then sequence length, data type, and load in 4-bit, you load in 4-bit. So you have loaded the original model and tokenizer. Okay, done. The next step is basically we'll first examine just to make sure that our LLM is unable to answer any question regarding this Damini product because it has not been trained yet, just to make sure. So from Unsloth the chat template, import get chat template, then tokenizer equal to get chat template tokenizer, and chat template equal to Llama 3.2. Then tokenizer dot pat token equal to token ES token in order to make sure the pat token to be the same as the EOS token to avoid the tokenization issue. So they are same. And then fast language model dot for inference. This model will be using for inference. Then here the message role user content. Then what is the primary function of the product Damini of the A to Z company? We are asking this question. And inputs equal to tokenizer dot apply chat template. We are applying the chat template on the tokenizer. Then message is equal to messages. Then passing the tokenize equal to true. Then other things will just follow. Add generation prompt equal to true. Return tensor equal to pytorch pt, padding equal to true, etc. The attention mask equal to input not equal to tokenizer dot pat token id. So it won't include the pat token id. It doesn't need to for inference. The output equal to model dot generate. It will generate the output. Input id equal to inputs, and attention mask, and all these things you have to. The temperature, that controls the randomness basically in response. The temperature 0.6 and all these things. Then finally you have to after getting this output, you have to decode the generated tokens into human readable text. So dot decode output 0. Then you can print the text. And so when you are asking what is the primary function of the product Damini of A to Z company, it will say that I cannot find. Okay, because it has not been trained yet. I cannot find any information on a product called Damini by A to Z company. The next step is to apply LoRA adapters for efficient fine tuning. For efficient fine tuning, we'll use the low rank adaptation technique. So model equal to fast language model dot get PFT, parameter efficient fine tuning model get PFT. Then pass the model already. Then that LoRA rank we have to specify equal to 16. Then target modules. So all the layers where the LoRA will be applied to apply the LoRA. So it contains the attention layer, non-attention layers, etc. The LoRA alpha we have to specify scaling factor 16, LoRA dropout, then other parameters also we have to specify, and then random state, etc. That is done, and then next we'll deal with the data now. So from dataset import load underscore dataset. So load dataset from the Hugging Face hub. Hugging Face hub just from dataset. So this JSON data, as you can see, basically we already made it in that format, So this is the one. So you can just copy and paste it there, or else you can save it in a JSON file and upload it here in the Google Colab in the files, and then you can specify the path. So I just this small data, I just copied and pasted it here. JSON data equal to that, as you can see. It's a list of JSON objects where there is a key conversation and under conversation. Then there are two dictionaries are there: role user, the content, then also role assistant content. So the first one is the question, second one is the answer. Then question answer, so on. A total 15 question, 15 answers, so that total 30. So this is the JSON data. So then from the dataset import dataset, the Hugging Face. And now we are going to convert it to the Hugging Face format, the dataset. So dataset dot from list, since that is a list of JSON objects, so from list and then pass this JSON data. So it will be converted to the Hugging Face format. So Hugging Face format here basically the feature conversation key is the conversation and number of rows 15. So Hugging Face format is the we need for the fine tuning Hugging Face format. So now it has been converted to Hugging Face format. We are all set now. So now we import Unsloth and then from the Unsloth.chat template import get chat template. Then here actually once the data set is prepared, we need to ensure that data is structured correctly to be used by the model. For this we apply the appropriate chat template. We have used the Llama 3.2 chat template here using the get chat template, etc. So it's very important. We have to structure the the data correctly actually, which will be fine tuned. So from Unsloth.chat template get chat template, then tokenizer equal to get chat template, then pass the tokenizer. You already have it here, and then chat template equal to Llama 3.2. You can specify the chat template format. Chat template for 3.2 Llama 3.2. So we have the tokenizer. And then we are defining for basically one function, formatting prompt function, passing the examples data, and the key is the conversation. As you can see, the convos means conversation equal to examples, and then we are applying the tokenizer here. Tokenizer dot apply chat template. We are applying basically the basically this function prepares the tokenizer with this chat template or chat format. So we are applying it here, and then finally we are getting this text in that right format. After applying this chat template, apply chat template tokenizer. So it will return the text then. So and then we are using this function. We are just mapping the function on this dataset, and we are converting it to that format. So now dataset has been converted to the dataset text. If we print, it will be something like that. So start header ID, then end header ID in this format only, something like that. And I have also printed this conversation, also the text both, and you can see the original conversation, that one, that's content, role, all these things, right? Content is this is the question, then role is the user, and then content, this is the answer, and then accordingly, and that role is the assistant here. And then after we converting it to the this format, then it will be something like that, that end header ID, start header ID, and end header ID. Okay, now we have to set up and configure the trainer. And so from TRL, which is Hugging Face library, just import the SFT supervised fine tuning trainer, configure the fine tuning process using the Hugging Face SFT trainer. So it automates the task like tokenization, batching, and optimization. Okay, then you import other things from the transformer, import training arguments, etc. Then Unsloth import is B float 16 supported all these things. Then define the trainer configurations. You pass the model, tokenizer, dataset equal to dataset, all these things, and maximum sequence length, maximum sequence length, all these things you have to pass, specify. And then here also we are going to run it for fine tune or train it for the 15 epochs. This is very important. Make sure you specify it 15 here. Learning rate 2e minus 4. I am not going to change it. Other things are there. The optimizer is Adam W optimizer 8-bit, and weight decay 0.01, and then linear decay of learning rate, that LR scheduler type linear. Okay, then after specifying all these things, we are done here. Then train on assistant response only. To improve the training efficiency, we will focus only on the assistant response rather than the user input. So we will focus on the assistant response or the answers only. So that is why from Unsloth.chat template import train on response only. So response only, train on response, or trainer equal to train on response only, and then you have to pass the trainer, which we have already defined above, and then we have to basically instruction part and response part. Instruction part, mark user input, start header ID user, end header ID. And here also response part, start header ID, assistant, end header ID. That you have to mark the assistant response. Then model will be trained, fine-tuned for 15 epochs, and as you can see, training losses falling nicely. Then finally, after 15, actually in each epoch 2 steps are there. Total after 30 steps means 15 epochs around, it will be 0.000700. So pretty good this training loss. So our model is now ready to be tested. Now we'll do the inference part. So inference part also same tokenizer get chat template, tokenizer pass and chat template, the Llama 3.2 chat template. Same thing, the tokenizer.pat token equals tokenizer.us token. Then this one fast language model dot for inference. We are doing inference and model. This time this is the fine-tuned model. So message. So we are going to ask one question related to this product Damini. What is the primary function of the product Damini A to Z company? Primary. That is the first question. You know, if you look at the PDF, this one, what is the primary function of the Damini? So the answer is the product is a cloud-based software solution that allows users to manage and analyze large datasets through advanced machine learning algorithm. So let's see what fine-tuned LLM says when you ask this question. So inputs equal to tokenizer.apply chat template, then pass this message, this question, then tokenizer equal to true, and add generation prompt, other things you can see. Return tensor equal to PT, PyTorch. So output equal to model.generate, input ID is equal to inputs, attention mask, attention mask, this one. And then temperature same, we are not going to 0.6, everything same. Then we are decoding the generated tokens into the human readable text here, and so we'll see the human readable output or answers. So what it answers? Let's see. The primary function of the product, which is a cloud-based software solution, is to manage and analyze large data set through advanced machine learning algorithm. So you can see it has answered correctly. So that means our LLM has been fine-tuned perfectly. So it could answer the question. So I'll show you the more questions and answers or inference with the more question and answers just after this one. But before that, let me tell you that you can save the model basically locally. You can save, so it will be saved in your basically colab local folder. It will be saved. Then you can download all, and you can also push it to Hugging Face Hub. That you can do. So I asked few other questions after fine tuning. So how does the product Damini protect my data? Then assistant, let's see what LLM or assistant says. So it says the industry standard encryption protocol, strict privacy policies, and compliance with the relevant data protection regulations. So let's go to our original PDF and see what it says. How does product Damini protect my data? So it says industry standard encryption protocol, strict data privacy policies, and compliance with the relevant data protection regulations. Same thing. So it has answered correctly. Then you can try more questions. So I asked this question also: what is the target audience of the product Damini? What is the target audience of this product Damini? Sorry, who is the target audience for this product Damini? Who is the target audience of this product Damini? And answer is data scientists, analysts, researchers, and businesses looking to extract variable insights from complex data sets. They are the customers. So let's see our what is there in our PDF. So who is the target audience of this product Damini? Data scientists, analysts, researchers, business looking to extract the variable insights from the complex data sets. Yeah, same thing. So as you can see, it has answered correctly. So our LLM has been fine-tuned really well. So let me tell you some important things, since our data set is small here in size, the 15 sets of question and answers. So it's very important to fine-tune or train it at least for 10 to 15 epochs to see the significant some results in the fine-tuned model. To see some significant results in the fine-tuned model, you should run at least, because data size is small, so you have to at least fine-tune a 10 for at least 10 to 15 epochs. So that's what I have done here. But if you, in your case, if in case your data set is large, too large, it's a huge PDF for the question answer. So you can following the same procedure, step by step procedures what I have explained. You can fine tune any large language model, which make sure that is a part of the Unsloth. So you can fine tune any large language model with your custom data, a question answer type of data. You yourself can prepare the data. I mean, doesn't matter how long it is, but if your data data is too long, it will require a lot of memory, hardware resources. If data is too long, data size is too much, then in that case you can fine tune for 2-3 epochs, and then you see what results you are getting. Actually, you can evaluate after 2-3 epochs and then check the results. You may get some significant results even after running 2-3 epochs if your data set is large enough. Yeah, so that is all for this video. I hope you liked it very much. If you like it, please give a quick thumbs up, and also please write your feedback or comments. I really love to see them. And also please do subscribe my channel if not done yet. A lot of interesting videos, very important videos will be coming up in the next few days or weeks. So please make sure you subscribe my YouTube channel. Thank you very much for your time. Thank you. Take care. Bye bye.